today's panel is on southbound interface for programmable data plane. And we have some technologies here. Just to get an idea, I just want to know if everybody knows about these technologies on the slides. Have you heard of them? Do you know in depth of what they are? So the panelists get an idea of how in depth they should go. So can I get a hand maybe to see how many of you know all of them? And so not many people. So we could go a little bit in detail about them. The main focus about this panel is to get an idea about the programmable data plane and also an advice for the ODL community, how to go forward in this domain. So to introduce my panelists, I have Michael Zayats from HPE. He is the distinguished technologist and architect of OpenSwitch. He'll talk a little bit about OpenSwitch in a minute. And then we have Prem from Barefoot Networks. He's the product line manager, and he leads different projects in P4 consortium. And then we have Dr. Haoyu, who is the chief architect at Huawei and has led the protocol oblivious forwarding, which is the POF technology. And then finally we have Jon, who is the distinguished engineer at Cisco and is also the engineer of the ODL technical steering community, and also of FIDO, which we'll be talking in a minute. So, and I am Anu. I'm a systems engineer at HPE. So we will probably go very quickly into the panel. So in today's panel, we have some key points that we want to achieve. One is to introduce these technologies to you all to find out what is a programmable data plane. And after that, we'll go into a deep down discussion about it. So please feel free to ask any questions at any point of time. We'll take audience questions, and if not, I have some questions prepared too. So we can get the panel to give us some ideas from their expertise and experience. And one of the important things is integration to the SDN control plane. So data plane goes to the next layer, and if it's programmable, how do you integrate it with the control plane? And finally, some use cases in general. So I have the different technologies here. I'm going to go ahead and ask my panel to introduce them to us. So Jan, you want to go forward? You can use the pointer. And you have a mic? Yeah.
Hello? Yeah, okay, perfect. Yeah, so I'll be talking a little bit about Fido.io. Who has heard about Fido so far? Almost everybody in the room, great. So it's a new initiative in the Linux Foundation, and it is designed to further the evolution of programmable networking. We have the dynamicism and the programmability and kind of flexibility happening in SDN, in cloud, in NFV, but one of the big unsolved problems is how to deliver network services in this more dynamic environment. Some attention has been focused on the non-local control plane, on controllers. I mean, they have kind of cornered all the limelight of the community, but the humble forwarding elements, they haven't really. There hasn't been a lot of work apart from OVS, so this is a new initiative that's aimed at addressing that. So what we need to really do is add dynamic data plane services. So the limitations of the existing data planes is performance, scalability, and stability. We all know about them. It's overly complex architectures which are hard to evolve. There's also the complex architectures mean that we have slow rate of innovation and a steep learning curve for developers who want to work on that. It's hard to deploy, and we also, because it's hard to deploy, there's lack of end-to-end system testing and support and portability, and also sometimes the architectures or the new advances in processor architectures are not being taken advantage of. So what is FDIO? It's a new project in Linux Foundation. It's multi-party, multi-project. What does multi-party mean? It means anybody can join, and you're more than welcome to come and start contributing, either as a company or as an individual. What does multi-project means? There is multiple projects. One is, for example, really the one that's developing core of the FDIO FIDO technology, the VPP. The other, for example, is the networking agent, Honeycomb. Some of you may have heard about that too. Anybody can propose a new project. So if you have some great ideas about new forwarding ways or doing forwarding or new protocol types or what have you, it's a great way how to park them, where to park them, where to do development on them. So what does it mean? This is the stack. This is basically what it's all about. It's about I/O, input-output, which matches or pushes packets between cores in a CPU and the I/O units. It's processing. It's a so-called VPP engine, vector packet engine. And then there's the management agent, which is basically a netconf agent that provides control for the other layers. Vector process processing, that's really the cool technology around which all this project is built around. It runs on commodity x86 CPUs, leverages DPDK. It's basically a vector engine. It creates a vector of packet indices and processes them using a directed graph of nodes. There's going to be a detailed presentation of the technology by Ed Warnicki later in a week, so I would encourage you to go and attend that. It's basically a Linux user space application. That's really cool and really important here to know. And ships part as both embedded and server products, and it ships in volume, and it's been actually in development since 2002, so that technology is quite mature. It's been only recently open source, but the technology is mature. When we look at VPP in the overall stack, you can actually see where it sits. It's in the data plane services along with DPDK. And we've got operating systems, controller, orchestration, VM management systems, and so forth. Now, one really interesting thing, since this panel is talking about the API between the controllers and the data plane services, you actually see OpenDaylight in this picture twice, in this picture. It's a network controller, but also the agent is based on OpenDaylight, the Honeycomb agent, and it's basically a really fast and high-performing netconf agent on the northbound. And the API between the controller, the preferred API between the controller and the VPP-based forwarder is actually netconf.
Yeah, okay, thank you. So next you probably will go with POF.
Good afternoon, everyone. Today I'm going to give you a very brief introduction of protocol oblivious forwarding. POF actually started as an internal research project within Huawei more than 3 years ago. At that time, most of the research actually focused more on the management plane and the control plane. But we were thinking the more fundamental issues, how we will involve the data plane to make it better suit for SDN's requirement. So the main issue we found on the current network is that network device, just a fixed function box, it's very hard for service providers to add custom functions or to modify its behaviors at runtime. So therefore, we have this vision of the open programmable data plane. So the key idea is we just open up the programmability of the network device and really hand this kind of flexibility to the service provider to allow them to customize their data plane. After we announced this idea and actually gave our first public demo in more than 3 years ago, there are some related industry activities actually keeping validate this idea. So the first noticeable one is probably the OCP networking project. So the key idea is to decouple the networking operating system and the device. So by doing this, it actually provides the abstract switch interface, then allow the user to write just one single program. Then it can be applied to heterogeneous data plane. Unfortunately, this architecture is still based on the fixed function ASICs, which means the user will have very little flexibility to modify the folding plane behavior. It can just to do some configuration and maybe manipulate some of the flow tables. So very little flexibility. So therefore, we actually move to the second stage. The second stage is embodied by the programmable chips and some high-level languages which we can use to program the underlying device. So this actually first time allow the user to customize their network behaviors. And also, now you have one device. Depending on what kind of software you installed to the device, you can really incarnate the device to different type of forms. For example, it can be a router, switch, or even a firewall or NAT gateway, anything you can imagine. But actually, the POF's vision stretch this a little bit further because we consider the network can be very dynamic. Some applications really need the real-time and on-demand modification of the data plane. Therefore, the POF actually supports the interactive programming, which means we can really modify the network behavior at runtime. So to realize this, you can see the POF architecture has this scene-based architecture. So the WIST is actually the standard intermediate representation and a standard interface we use to configure the device and also run the runtime control. So there are three key defining properties of POF is that it's language independent, which means we can use different type of high-level language to program them, as long as all this language can be compiled to the standard IR. And also it's a protocol independent, which means user can freely design their own runtime protocols running on the folding plane. And the last is target dependent, which means the folding plane actually can be built with different type of chips. Either it's NPU, CPU, programmable chips, FPG. They just need to comply with this standard source-bound interface to be able to communicate with upper layers. So and the last point is, since you have a single source-bound interface to support both the configuration time and the runtime, it really supports this interactive programming for real-time and on-demand applications. So the architecture is very simple. The folding plane abstraction just based on this table action pipelines and with very simple attached to the input port and output port. The main programming point is this action. Action can be used, or we define a set of instructions, and we use this set of instructions to program this custom action. And these actions can be dynamically loaded to the data plane. And for the tables, there's basically each flow entries can use some pointer to point to a different custom actions. So therefore, we can dynamically change it at runtime. And also, there are some dynamic shared resources which can be addressed from each custom action. But with these mechanisms, we can easily support the stateful data path processing. So we have made a lot of progress since we introduced POF. Right now, we already have this NE40E-based full-stack POF, which means now we can support language like P4. And we have the source-bound interface, which is basically the extension of the OpenFlow. And we have the hardware-based platform. And we also actively work in the ONF to work on the next gen of the OpenFlow specification. In this ONS, we will showcase one killer application, which can take advantage of the POF's capability. We call that dynamic network probes. And the next step, we are thinking about how to integrate POF into the mainstream SDN controllers, such as ODL. Yeah, thank you.
Good afternoon. Can you hear me? Yes. Okay. My name is Prem Jonnalagadda. I'm a product line manager at Barefoot Networks. I also moonlight as a community manager at p4.org. I'd like to give you a brief introduction of P4. P4, as you can see, stands for Programming Protocol Independent Packet Processors. So let me start with a bunch of questions. Today, how can you quickly deploy new protocols in your network? How can you see what your forwarding plane is doing? How do you own that forwarding plane and the intellectual property that's in it? How do you tailor the network to meet your needs? And how do you write code that goes into your forwarding plane that can be portable across multiple devices? Today, the answer to these questions is, it's very difficult or not possible in some scenarios. So what do we need? What do we need to be able to essentially get ownership of the forwarding plane and the IP that is in it? We need a couple of things. One, we need programmable switch chips or programmable forwarding plane. And then you need, it'll be good to have an industry-wide programming language that can program or specify the behavior of these forwarding planes. So that's where P4 comes in. So let's see what P4 is. P4 is a programming language. If you don't take anything away from this presentation, take that away. It's a programming language. It's not only a programming language, but it's a high-level programming language, meaning it's easier for software engineers to, read and code in this language. Another interesting thing is it's networking domain specific. It's not a compute specific language or some other type of target. It's networking domain specific. So it operates on an abstract forwarding model that is geared towards networking. So it makes it very easy to specify networking behavior or networking features in this language. And then this language doesn't really know any protocols. So it's protocol agnostic or protocol independent, meaning you can define the protocol in this language. The language inherently doesn't know any protocols. And last but not the least, P4 has been around for a few years. It's gaining adoption, and also the ecosystem around P4 is growing quite rapidly. So P4 and OpenFlow are kind of talked about interchangeably, or one is the replacement for another. So just wanted to clarify that a little bit. If you can see this picture, P4 is playing on the side over there. A developer or a networking software engineer writes a P4 program that describes the forwarding plane. He compiles that program, generates a binary or configuration that goes into a target, and then the compiler also generates API to control that pipeline. So it all resides in the forwarding plane. Now, how do you access that forwarding plane? You can do it through traditional driver and protocol stacks, or you can use OpenFlow. OpenFlow, you would use an OpenFlow controller like OpenDaylight or others. Use the OpenFlow protocol to talk to an OpenFlow agent that is sitting on top of a driver that's controlling the P4 pipeline. So that's the distinction between P4 and OpenFlow. Now, the P4 program itself and compiling it and downloading it can be folded into the controller side of things. That is something that'll be good for the ODL community to look at. There are people looking at it, but it's a possibility. It's something for the future. Now I'm going to talk a little bit about the P4 language consortium itself. This consortium exists to create an open source community around this language. And also working on evolution of this language, different versions, adding new features. A lot of the companies that are here are members of the p4.org. Membership is free. Everything is open source. All you need to do is sign Apache 2.0 CLA to join. The website and the GitHub links are over there. Just to kind of give you a snapshot of current members, there are about 40 organizations from industry and academia, about 34 from the industry, 6 from academia. And everybody in the networking industry is represented here. Cloud service providers to software vendors. Everybody that wants to get control of the data plane or forwarding plane are here. Some of the links here, just showing you there's resources. It's kind of hard to read, but maybe when you get a copy of the slides, you can go look at it. There's a compiler, there's a spec, there's a full function L2, L3 switch pipeline, open sourced. You can also use a packet test framework to test your pipeline if you want. So now, if you have all of this, what can you do? There's a bunch of things I added here, but essentially it gives you ownership of the forwarding pipeline. It gives you ownership of the IP that's in the pipeline. You can keep your IP from going to your competitors. And you can modify your network whenever you want. Essentially, it gives the control into the end user and helps networks be designed top-down rather than bottom-up. What do you do now? There are ways to get involved. Join p4.org. Try out the software that's already out there on GitHub. You can also join us in upcoming events. There's actually an OpenSwitch booth at ONS where we'll be demonstrating a P4 pipeline soft switch controlled by OpenSwitch. There's also P4 workshop coming up. Finally, join the mailing list. That's where all the information gets disseminated. Thanks. Are we taking questions? Yeah. No. Go ahead. Yeah, I will.
So, what is really the need of P4 in the presence of OpenFlow? Do you see any gap within OpenFlow?
Oh, yeah. I think I kind of addressed that. If you go back. Oh, sorry. So what's the question was, what is the need of P4 in the presence of OpenFlow, right? OpenFlow gives you access to a pipeline, right? So if you see most fixed function ASICs, they have a level of abstraction using TTP, and then you get access to that abstraction using OpenFlow, correct? But P4 allows you to change the underlying layer. So for example, if you have a device that does protocol A and B, you can access those protocols using OpenFlow, but you cannot implement protocol C, right?
So what really confuses me is the forwarding plane that you have over there on the top.
Yeah.
So is it like forwarding plane, are you talking about the flow switching plane, OpenFlow switching plane?
That's a good question. So the forwarding plane there can be a soft switch or, so sorry, the question is, what is that a forwarding plane in this picture? Is it like a, what did you say?
So like an
OpenFlow switch. Correct. Right, so the forwarding, what is the forwarding plane? So it can be a soft switch, an OpenFlow switch. It can be a completely traditional L2, L3 switch that you write using P4 program. It could be, let's say there's a P4 programmable chip. It could be that just takes a P4 program and runs it, right?
So does the output coming out of your compiler is going to be different for each type of system?
The question was, does the output coming out of the compiler be different for each solution? And the answer is yes, yeah. So there's a front-end compiler that kind of gets you to compile the P4 program, generate an intermediate representation. Then you can map that to a backend compiler to any target you want. There's a few backend compilers already out there, mapped to FPGAs, NPUs, Even GPUs, somebody mapped a P4 program to a GPU to do flow tracking and things like that. So, yeah.
Thank you. And finally, open.
Hello, everybody. My name is Michael Zayats, and I work for HPE, and I'm the architect of OpenSwitch project. So Prem just mentioned OpenSwitch and how OpenSwitch works with P4, so I will give you a little bit more overview about what the project itself is about. So we started this project we launched the project about 6-7 months ago, and the objective of this project is to create a fully open source and community-driven operating system for the switches. So we are not talking about virtual switches, we are talking about physical switches, and we want to basically fill the gap of not having completely available and free operating system for those devices. So so if you want to think about, parallels, it's more similar to like Cisco Nexus OS, Arista OS, these kind of systems. We don't want to develop just a system that will support only just OpenFlow. It's the traditional operating system with layer 2 features, layer 3 features, everything, and OpenFlow, of course. The configuration is available through different protocols, the northbound interface. There are many different northbound interfaces, and we'll talk a little bit more about OVSDB as we get to it, because there is some relationship to Open Virtual Switch. So, first of all, what's important for me to stress out is the fact that we are building a community. So right now we have very active mailing list, RC channels, people contribute code and work together, and everything is Apache 2.0 and stuff like that. So if you can see, here you can see all the companies that actually work together with us, all the ASIC vendors actually work on developing drivers for the system. This slide, well, it's very difficult to see anything on this slide. But on this slide, generally, I spend like 30, 40 minutes. And whoever is more interested can actually visit our booth tomorrow and on Wednesday. And we will also host some session tomorrow as well to go deeper into this one. But what is more important is to understand that OpenSwitch is very much based on Open Virtual Switch. So we grab many of the architectural pieces out of Virtual Switch. So we have OVSDB server in the middle of the system. That's very much a state database driven system. And this is the main kind of control interface, management interface for the system. We also have all the different layers, all the different plugin layers at this place that allow us to connect to different ASICs, to provide different drivers. And one of them is, for example, P4. So right now we are running on physical switches, not on virtual switches, but we also have the target which creates OVA and creates Docker containers, and we actually test this way, and we create platform-independent pieces this way. So we have P4 integrated, so we can run on top of P4 data planes. And since we're based on Open Virtual Switch, then we have OVS agent. So we have OpenFlow built in. So right now, Broadcom actually contributes the support for OpenFlow in OpenSwitch OpenNSL drivers. Current status, we are getting very feature rich. We are getting all the different features. OpenFlow is being added by Broadcom, as I said. We are getting P4 support. We have Broadcom drivers, we have Barefoot drivers with P4, we have Cavium drivers. Mellanox actually already announced that they build the side drivers for us. And some additional ASIC vendors are coming in. And we actually target to have some first stable release in about June, July timeframe. Okay, thank you.
All right, thanks. Thank you. Actually, you can. All right, so now that we have all the concepts in place, the next thing we want to go into is the questions, right? So after the panel proposal was accepted and the panel was decided, it took me some time to figure out how do we put all these things together. So we have FIDO, we have OpenSwitch, we have P4, POF, right? So OpenSwitch is a network operating system. FIDO is fast data performance. You have P4 and POPOF, which are compilers, right? Language compilers in the switch. So taking the concept of ODL in place, because this is an ODL mini summit, and all our data plane programmable technologies are actually controller agnostic. So I want to drive this panel in such a way that we get an idea of why do we need programmable data plane, and also what is the direction for ODL. Let me just start off with a question to the panel asking, why do you think, from your perspective or from the projects, from the projects that you've given to the community, what is the reason that we need a programmable data plane? Why do you see that there's a need for it?
As I said in my presentation, I mean, we need the flexibility and the speed of feature delivery and the dynamic nature that we see in the upper layers of the stack, in the applications, in SDN, in NFV control plane, if you will. We need the same flexibility and the same feature velocity in the forwarding elements themselves. That's a very simple reason.
I like to approach this question from the service provider's perspective. Service provider has two key requirements. The first one is to reduce their system cost. I think this open data plane actually, so first the key point is decouple the control plane, the forwarding plane, and really enable the kind of can help service provider to avoid the vendor lock-in issues and provide an open ecosystem. And secondly, you have a fully customized application. So it's totally user controlled. So for the same hardware device, you can install different enabling softwares that will extend the product's life cycle. And also you can have fully customized applications. Actually, you can dedicate the entire resource for the single application that, on the other hand, it can help you improve the efficiency and lower your system cost. And another requirement is to generate new revenue. And since now the user control the programmability, you can, the service provider can have its own secret sauce and have its own differential services. They no longer need to rely on the vendor to provide it to them. They also don't need to reveal this application to others, and through the software means they can deploy the application, the service much faster, so it shortens the time to market. So it's another way to increase their revenue.
Yeah, I echo Haoyu's thoughts on this. I think programmability has existed in compute for years, and networking is actually late to the game. And networks these days are growing fast. The demands on the networks are changing rapidly. And if you really don't have control on the forwarding plane, you don't adapt to the changing needs fast enough. So programmability is essential in networks of today to be able to change fast, adapt to the needs, and basically build better networks.
I will try to go a little bit into the use cases that we hear a lot from the customers, and that's more about the way of gaining more visibility and monitoring capabilities into the networks. And it gets us all together into this programmability stuff, because in order to get this visibility, understand what happens, and then close the loop and actually act based on this understanding, we need a way to actually affect the traffic in a very dynamic way, in the way that the system that should allow the applications to actually come in and redirect the traffic. So if we understand that, okay, this is the application and this is what happens in very dynamic situation, we need the ability to actually reprogram the network very, very rapidly. So visibility is now key for the customers, and the ability to close the gap, to close the loop, and affect the traffic based on this visibility is very key as well.
Great, thank you so much. So do the audience have any questions? Yeah. Okay.
Yes, so this looks like a possible replacement for custom vendor ASICs and line cards to allow customization of the program of the forwarding plane. What do you think at least the initial performance of these things would be if you're dealing with line cards that are working on 100 gigabit or 10 gigabit speeds? Is it realistic to think that some of this stuff is capable of operating at those speeds?
Just to rephrase just to repeat the question for the online recording. So for line cards which have really high data rate, how is the performance we can see with the programmable data plane? If that's what.
Yes, and is this targeted at replacing some of those vendor-specific ASICs?
And targeting replacing vendor-specific ASICs. Okay, cool.
So I can try and answer it a little bit. There will always be some restrictions on the flexibilities inside the ASICs. ASICs will never be completely 100% flexible as the software data passes. However, we already see the first batches of flexible ASICs that are in production or very close to production that provide same performance as the classic ASICs, and provide almost full flexibility. So we see them in production, some companies, and some companies are preparing them very soon.
Yeah, we have some experience on building this prototype. Our prototype is based on the network processor. So the first gen prototype is on 40 gig MPs, and the second gen is on the 200 gig MPs. So we did see some performance loss due to the compiler inefficiency, but pretty close. So we are keep working on the compiling technologies and making the performance close to the line speed processing.
So what you see with VPP is near line card or near dedicated hardware performance. I mean, something that was in dedicated hardware a couple of years ago is now achievable on general purpose CPUs. So VPP gets about 40 million packets per second out of a single core today. So that's significant performance, and as the cores or the number of cores in a given CPU goes up, the performance will go up. So we will see in near future what today is like high-end line cards could be replaced by general purpose compute hardware in the future with this technology.
Yes. Oh, you want to? Sorry.
Yeah,
Prem?
I just want to add something. So you asked about performance and programmability, right? So achieving performance with programmability has been hard. But if you look at the merchant silicon today, that's the top of the line. You have one that is, not that flexible, and we have another one that is completely flexible. So it's already been shown that you can achieve performance with flexibility and programmability.
Yes, you had a question. I'll probably come back to you. Okay, go ahead.
So you guys are discussing, you have POF, you have P4, there's other programmable languages out there, NetAS and a couple others. So it's sort of like a fracturing of this ecosystem here. How do you see these kind of coalescing, or are we looking at like a VHS versus Betamax format war, if you will, here between these different programmable architectures?
So,
What do you see 5 years from now? Do you see any one clear, I don't want to say winner, but obviously everybody's going to go towards in one direction.
yeah, so the question was who's going to be the winner? That's a question, good question, because we have different languages and how do they coexist? So if I were to say the panel.
Well, that's an interesting question. It's like if VHS and Betamax was here and you were asking them who's going to win, they both will say they will win, right? I think it's slightly different, though. I think Today, what's happening is based on a particular need, there are things being done, and there is similarities between these things. There's a lot of overlap, but there's also differences. So how will it be in the future? That depends on how how the network needs are, and how the ecosystem builds around these technologies, and a lot of factors. But I think at a high level, what you're seeing is the need for more control in networks and visibility. I think Michael brought up a really good point, which is networks need visibility, and you have choice of things that you can use to achieve that, and we don't know.
At a certain level, who cares? I mean, it will be decided by the marketplace and the communities that these particular technologies will be able to attract. And may the best community and the best technology win.
Yes.
I have a couple of questions, if you don't mind. So the first one is, I came from a forwarding background. I used to be a microcoder before the MPUs. So I fail to understand any of those models. How are you guys handling with the distributed forwarding model? Being multi-line cards with the fabric in the middle, and you have sometimes you have a first stage, second stage, third stage, depending on the vendors. Most of the things most of the examples that you guys provide is just really one stage. You figure out everything in one line and just do the rewrites, and you just see the back. Sometimes we need those multi-stage for things like multicast. How you guys are handling multicast, for example? That's one of the things. And it really heavily depends on the actual hardware, what we call the chassis, whether it's doing a fabric multicast or doing a application-based multicast, and things like moving. A lot of details about this. Okay, so this is the first question. If you can kindly address one. The second question is, actually I lost it. So
Okay. So the question was how do we address the issue of multicast if as an example, and
So actually, we define just a very abstract model, and we do support multi-stage processing. And for the multicast, the underlying mechanism is to replicate the packet to multiple ports. So with the existing instructions, we can easily to support that. So am I answer your question? No?
any dependence on the actual hardware?
dependent.
How is your router designed? Is it like there's an ingress processing, there's a middle stage, there's an ingress processing, any
Oh, okay. So on our data paths, actually, there are multiple modules, right? The packet processing and the traffic manager. And so far, our focus is on the packet processing pipeline. So that part, you can consider other modules like virtual ports or black box. But this part is currently the programming point.
So since these engines are programmable, you can actually define your own stages, and that's what you do with VPP. You define like a graph, which the code then goes on the graph, and each basically node in a graph could be understood as a stage. So I encourage you to attend Ed's presentation later in the week where he will go into details of the technology. But similar principles that you see in hardware can be found in these engines as well. Oh, Ed just joined the room. I was just talking about you. So when's your presentation about FDIO?
So FDIO, there's an FDIO intro at 4:10 on Wednesday.
At 4:10 on Wednesday.
And then there's a meetup at 5 p.m. on Wednesday.
And the meetup at 5 p.m. on Wednesday.
Yep, so the presentation's in one of the grand ballrooms. The meetup is in Napa. That would be so much more fun with a little
So anybody else in the panel want to answer that question?
Okay, so the second question, I got the second question.
Okay.
About overlays and underlays. Are you guys flexible with implementing overlays and underlays? And the reason for this question is that usually those coming from different points. Like, for example, if you are a carrier provider, you provide the underlay, and then if you're a service provider, you provide the overlays. If you're application, you have another overlays and stuff like that. And those are built supposedly to be independent of each other, because graphics and all those preferences and priorities and stuff like that. Is any of your kind of like forwarding, programmable forwarding handles overlays and underlays?
Yeah, so in OpenSwitch, what we do, we actually model them pretty much separately. So, for example, underlay is going to be managed by BGP and other stuff, and overlay might be managed just by OpenFlow. So that's exactly the model that is being contributed right now by Broadcom into OpenSwitch. So underlay, because in many data centers, that's what they actually want. They want the underlay to be more of the traditional routing protocols, and overlay to be completely programmable. So that's what we're going to do.
Okay, any other questions? Yes.
I'm confused by this one project. Looks like they are all software switch as a model. So I think this project needs to replace the OpenDaylight, right?
So the question is, are these projects to replace Open vSwitch? The answer, I think it'd be better that they give, but I think the answer is no.
No, actually the answer is yes. The VPP and FDIO would be a replacement of Open vSwitch.
And OpenSwitch is not supposed to replace it because we are basically running on the physical hardware. We are not running on the virtual switches. We have virtual option because for development, for testing, but not for the real deployments.
Yeah, but for POF, I think I mentioned in my slides, it's a totally targeted independence, which means it should work for both hardware and software-based platforms.
Yeah, I think similar for P4, right? Actually, yeah, can you use P4 to define an Open vSwitch-like pipeline? Answer is yes. But again, the needs are different, the deployments are different. I mean, it can be done. Actually, one of the things the Open vSwitch guys have done is actually taken P4 to describe the parser in OVS. So there's synergies. There's also complementary stuff going on.
I would encourage you to look at the light reading report back in December, where they compared the VPP performance and the OVS performance, and there's all kinds of measurements that they have done, and very interesting results came out.
To probably.
VPP uses DPDK as well.
Say that again?
VPP or FDIO uses DPDK as well. That's the I/O portion of the overall solution. Yeah, under a lot of circumstances. Yes, but that's just the I/O. Then you have to look at actually the forwarding performance, which is very different between OVS and VPP.
Maybe I
Please look at the light reading report, actually the EANTC report that has been done and published by Light Reading back in December 2015.
Maybe to just extend that question a little bit. So FIDO, replaces OVS, and OpenSwitch extends OVS and it reads through the OVS DB. And of course, P4 and POF have trying to, kind of get rid of it. So why is the reason that we are going against or not trying to replace OVS? I mean, of course, the performance, but can you give us more, enlighten us more on that?
So just to clarify, OpenSwitch doesn't extend OVS. It reuses major components of OVS on the physical switches, right? So we reuse the OpenFlow agent, we use the Open vSwitch database, we reuse many of the infrastructure pieces, but we are not coming to replace, and we are not coming to kind of build on top of it. We're not in the virtual switching at all.
Okay. So what are the problems of OVS that the programmable data plane or the efforts actually address?
So if you put two prefixes or two MAC addresses into VPP and OVS, it's going to perform about the same. If you put 20,000, then OVS starts going down. If you put 200,000, that's about, OVS cannot really deal with that, and VPP deals with no problem. You put 2 million, VPP can deal with that, OVS cannot. Mm-hmm. So the scale and performance at scale is very, very different with VPP than what it is with OVS.
Any other questions? Yes.
So for each of the projects, in your perfect world, what would your interface look like to OpenDaylight?
OVSDB protocol for me?
I think that's a question for the ODL community, but some southbound interface that talks to P4 data planes. I think that's still under, research, I guess.
Would it be anything other than OpenFlow?
It doesn't need to be anything other than OpenFlow. It can be, though.
Yeah, I think currently the SD controller still think the device already programmed. It has already have function in it. And what this proposal really did is actually before the runtime, what happens is you have a box with nothing in it. You need to have a means to program it, to give it some forwarding functions. Then starting from there, your controller take over the runtime control and configuration. So I think there's a new things that doesn't exist before.
Netconf, no question about that. As we have shown, actually, OpenDaylight is in FIDO. It's the Netconf agent for VPP. And we think Netconf is actually a much better protocol than anything else between OpenDaylight and the agent on VPP. We have just done some measurements last week, and it performs about 10 times better than OpenFlow, pushing routes or prefixes going down from the controller to a set of switches or a set of Netconf devices. So it's much better performant. It has security. It has the flexibility because you can define whatever model you want. OpenDaylight can just suck that model in, generate code on the fly. An application can immediately use whatever model the Netconf device provides. So it's by no means the most performant and the most flexible solution for them all.
Thank you. So I also had a question emailed to me by Inder Monga, who's the CTO of ESNet. So the question goes, how would carriers, enterprises, or data centers best use the programmability in data plane? Can you cite some early use cases that you're targeting?
Yeah, I will also mention we are working on a project to enhance network visibility. We call that dynamic network probes. So basically, it allows the service provider to dynamically install the probes into the network device at any place and any time. So then start from there, the user can get retrieve data from data plane and then run some sort of a big data analytics algorithm to analyze this data and further use this data to change the network states. So I think this is a very important application that all the service providers are looking for.
Yeah, I think I agree. Visibility into the network has been a challenge for any networking guy. I've heard of stories where something goes wrong in the network. The compute guy comes with reams and reams of data, and the networking guy comes with like ping and traceroute and not much else, right? So visibility into the network is critical, and when you have a programmable data plane, you can export data from the data plane to whatever remote monitoring agent and gather information about the problems. One of the things we've done is in p4.org that's there is the in-band network telemetry. So it allows you to export metadata from the switches in the packets, in the data plane packets, out to any remote collector. So it gives you full visibility in the network. And this is one of the things that any network can take advantage of with a programmable data plane.
And just to complement on the visibility side, the way we did it inside OpenSwitch is that we are pushing all the information of the device into the database, and we allow everything to be subscribed about. So for example, you can subscribe to the changes in MAC table, you can subscribe to the changes in LDP, you can subscribe to everything, right? So the operating system is providing full visibility into the device with everything you want through the same protocol, through OVSDB protocol, and the controller can fetch completely everything about it. So if you need to build a topology based on LDP, you don't need to forward it to the controller. You can actually ask the switch, hey, whenever LDP information is changing inside your database, tell me. And it will just tell you what happens. So all of this visibility should come together in order to provide this complete visibility into the network.
Yeah.
Yeah, we're also starting to see a lot of network virtual functions that are being built on this technology, and things like service function chaining. It helps a lot.
Yes. Yes.
So I would assume that one of the target places for these chips, the hardware portion of this, would be in big server blade farms where you could implement a lot of the software functionality and get the hardware forwarding that you might achieve with standalone vendor routing switching products. Would that be a true statement? Do I get bonus points for stumping the panel?
Yeah, so to repeat your question, you're asking about vendor lock-in. If there were to have vendor lock-in, how do we?
No, more of, is the target, one of the key targets for these chips to go into server blade farms, let's say, to provide higher performance for the data plane in an NFV environment?
The way we see it mostly today, it's going into top-of-rack switches. So that's the first and foremost application that we see right now.
Okay.
The use cases of. Any other questions from the audience? Yes.
So I guess much of the things you guys said apply to like a network device. So, and I'm wondering in the context of a large scale public cloud platform, does any of the work you guys talk about, how does that apply and what things we may want to watch out for? Because in that context, we have to have, we kind of prefer data plane programmability at each host level, and that's a kind of different problem because you have a lot more devices, and presumably each device does not provide as much computing power as like a network device like a router or switch.
Yeah, so just to repeat that question for the recording. So it's for a large-scale deployment, how do we tackle the problem? At a host level, how do we tackle the problem of programming the data plane?
Well, again, with the VPP ODL solution, first of all, VPP, for a given amount of CPU power, if you will, gets you the best available forwarding performance. Second, it's a user-level process, so it's very easy to deploy. From the OpenDaylight side, again, the scalability of NetConf is much higher than any other southbound. We have just done the measurements last week. You can easily attach up to 10, 20,000 devices to a single controller instance. So again, I mean, with the combination of the high performance programming and a protocol, scalable protocol between the controller and the devices, you get the high scale deployment.
Okay, so we are almost out of time. So I want to quickly wrap up the whole session so that we have a point to take away from the panel. So each of you, can you give a short statement on what it is to the ODL community that can take away from programmable data plane? Because if you see Beryllium release, we have a lot of southbound rendering interfaces. But how would the different projects play a role? I know FIDO already has Honeycomb Agent, but how do we extend that, or how do we incorporate it into the next release or future releases? Mike?
Okay, so basically, the plumbing and the infrastructure is there. It's going to be about the models for the NVFs and for the new exciting forwarding functions that are going to be provided by VPP-based devices and NVFs. And the ODL community has all the tools in OpenDaylight to actually use those models and start creating some exciting applications.
Okay, so as I just said, so this programmable data plane brings something totally new to the current data plane, and the ODL need to augment it to support this by including the programming phase into its design. Also, at runtime, if you want to support this interactive programming, which means in most cases, current models basically assume the north side application is actually is a protocol agnostic, which means it doesn't touch the details of the physical plane device details. But if you do this programming, you do need to touch on that. So I think there's still some difference here. I think the ODL architecture need to look at.
Yeah, I think I echo the same thoughts. If you are in the ODL community and you're a developer in ODL community, I encourage you to take a look at P4. Start coding in P4, and in the future there might be P4 programmable data planes coming. So it'll be good to figure out how to support these data planes in ODL. I mean, through OpenFlow you can do it already, but as Haoyu was saying, programmable data planes create new paradigms for networking. So it'll be good for the ODL community to take a look at that. I'll go to the P4 community and encourage them to look at the ODL community and stuff on the flip side. Thanks.
So I'll probably just go over, we'll recycle kind of the previous answers. One is, from visibility perspective, demand from the devices and from anyone that you're talking to provide you full visibility into what happens inside it, because without it you will not really be able to provide the real value of the controllers and the applications on top of you. And second is, think about this overlay underlay level, because we see it a lot of the underlay being the traditional and overlay being the flexible, and see how you can actually accommodate it inside OpenDaylight community, because that's very prevalent use case that we start seeing.
Great, thank you so much. Please join me in thanking the panelists for their time. And today's panel is on southbound interface for programmable data plane. And we have some technologies here. Just to get an idea, I just want to know if everybody knows about these technologies on the slides. Have you heard of them? Do you know in depth of what they are? So the panelists get an idea of how in depth they should go. So can I get a hand maybe to see how many of you know all of them? And so not many people. So we could go a little bit in detail about them. The main focus about this panel is to get an idea about the programmable data plane, and also an advice for the ODL community, how to go forward in this domain. So to introduce my panelists, I have Michael Zayats from HPE. He is the distinguished technologist and architect of OpenSwitch. He'll talk a little bit about OpenSwitch in a minute. And then we have Prem from Barefoot Networks. He's the product line manager, and he leads different projects in P4 consortium. And then we have Dr. Haoyu, who is the chief architect at Huawei and has led the protocol oblivious forwarding, which is the POF technology. And then finally we have Jon, who is the distinguished engineer at Cisco and is also the engineer of the ODL technical steering community. And also
talking a little bit about Fido.io. Who has heard about Fido so far? Almost everybody in the room. Great. So it's a new initiative in the Linux Foundation, and it is designed to further the evolution of programmable networking. We have the dynamicism and the programmability and kind of flexibility happening in SDN, in cloud, in NFV, but one of the big unsolved problems is how to deliver network services in this more dynamic environment. Some attention has been focused on the non-local control plane, on controllers. I mean, they have kind of cornered all the limelight of the community, but the humble forwarding elements, they haven't really. There hasn't been a lot of work apart from OVS, so this is a new initiative that's aimed at addressing that. So what we need to really do is add dynamic data plane services. So the limitations of the existing data planes is performance, scalability, and stability. We all know about them. It's overly complex architectures which are hard to evolve. there's also the complex architectures mean that we have slow rate of innovation and a steep learning curve for developers who want to work on that. It's hard to deploy, and we also, because it's hard to deploy, there's lack of end-to-end system.
FIDO, which we'll be talking in a minute. So, and I am Anu. I'm a systems engineer at HPE. So we will probably go very quickly into the panel. So in today's panel, we have some key points that we want to achieve. One is to introduce these technologies to you all to find out what is a programmable data plane. And after that, we'll go into a deep down discussion about it. So please feel free to ask any questions at any point of time. We'll take audience questions, and if not, I have some questions prepared too. So we can get the panel to give us some ideas from their expertise and experience. And one of the important things is integration to the SDN control plane. So data plane goes to the next layer, and if it's programmable, how do you integrate it with the control plane? And finally, some use cases in general. So I have the different technologies here. I'm going to go ahead and ask my panel to introduce them to us. So Jan, you want to go forward? Let me. You can use the pointer. And you have a mic? Yeah.
Hello? Yeah, okay, perfect. Yeah, so I'll be doing testing and support and portability, and also sometimes the architectures or the new advances in processor architectures are not being taken advantage of. So what is FDIO? It's a new project in Linux Foundation. It's multi-party, multi-project. What does multi-party mean? It means anybody can join, and you're more than welcome to come and start contributing, either as a company or as an individual. What does multi-project means? There is multiple projects. One is, for example, really the one that's developing core of the FDIO FIDO technology, the VPP. The other, for example, is the networking agent, Honeycomb. Some of you may have heard about that too. Anybody can propose a new project. So if you have some great ideas about new forwarding ways or doing forwarding or new protocol types or what have you, it's a great way how to park them, where to park them, where to do development on them. So what does it mean? This is the stack. This is basically what it's all about. It's about I/O, input-output, which matches or pushes packets between cores in a CPU and the I/O units. It's processing. It's a so-called VPP engine, vector packet engine. And then there's the management agent, which is basically a netconf agent that provides control for the other layers. Vector process processing, that's really the cool technology around which all this project is built around. It runs on commodity x86 CPUs, leverages DPDK. It's basically a vector engine. It creates a vector of packet indices and processes them using a directed graph of nodes. There's going to be a detailed presentation of the technology by Ed Warnicki later in a week, so I would encourage you to go and attend that. It's basically a Linux user space application. That's really cool and really important here to know. And ships part as both embedded and server products, and it ships in volume, and it's been actually in development since 2002, so that technology is quite mature. It's been only recently open sourced, but the technology is mature. When we look at VPP in the overall stack, you can actually see where it sits. It's in the data plane services along with DPDK, and we've got operating systems, controller, orchestration, VM management systems, and so forth. Now, one really interesting thing, since this panel is talking about the API between the controllers and the data plane services, you actually see OpenDaylight in this picture twice, in this picture.
it's a network controller, but also the agent is based on OpenDaylight, the Honeycomb agent, and it's basically a really fast and high-performing netconf agent on the northbound. And the API